Hello and welcome back to the Sculpt Tool Projector mini-series. And in this video, Lee, I believe you're going to be creating the custom shader that we're going to be using.
Yes, I am, and I am not going to be explaining every single bit of this in depth. As a matter of fact, I'll probably just barely breeze over enough of it, but I will be typing this in code, so you will be seeing your first custom shader. There are plans for entire sets of videos covering the way shaders are constructed inside of Unity in depth, as well as getting into probably some HLSL code or CGFX code, which is also embeddable inside of Unity shaders. But that will be stuff that will be covered in videos other than this one. We just need to get a very simple shader working so we can get our sculpt tool drawn on the terrain. So with that being said, what I'm going to do is take our existing projectors and I'm going to nuke them. We don't need them anymore. They have served their purpose. I'm going to create a new folder. And folder, where's
At the
my
top.
folder? Hey, there it is.
All right.
Yeah, you know, the brain stops working at 5 in the morning. So we're going to call this one shaders. Now, I'm doing this way because I wanted to bring up the default shader. So if I find shader, it's in here somewhere. There it is. Give it a new name. This will be S underscore sculpt. And if we open this guy up, yes, I want you to reload in this case. So here is what the default shader looks like. Now this is written in Shader Lab, but there is the possibility of writing CG programs which are your traditional or your more traditional vertex and pixel shaders. We don't need any of that. We're going to be using a straight up just Shader Lab shader. We can use all the built-in functionality. And they have this really weird way of indenting stuff which drives me nuts. But I wanted you to see what happens if you bring up one of the default ones. So this is what it looks like by default, and this is what we're going to do with it. Okay, now let's get started. We need to define this as a shader. We need to tell it where we want it to show up at. So we're going to tell it to create a folder called projector if one doesn't already exist. And from there, we need to give it a name. This will be our sculpt tool projector. Now, this will set up our first set of brackets. Inside of here, the very first thing we're going to need for our shader is a list of properties. So these properties are going to be the things that are going to be exposed inside of our inspector that we can adjust. So I want to have a color. We're going to call that color, oops, wrong one. We're going to call that color main color. It's going to be of type color, and it's going to have a default value of 1, 1, 1, 0. So, of course, that kind of dumb to have an alpha of 0, so we'll make it 1 all the way across. Now, I know I didn't say I was going to go in depth with the stuff, but what I do want you to know is this part, the underscore, and this name, this is the tag that's going to be available to you when you go into a material and you tell it to set a particular property. It's looking for this. This part of it is what gets displayed inside of the inspector as what this property is. This is the type of property, and this part is default parameters, and there's other functionality that you can define here depending on what you're setting up. The next thing that I want to do is set up a property called stencil. Our stencil is going to be called stencil. It's going to be of type 2D. Default is going to be gray. And I'm going to set this to have text gen object linear. And I'm not going to explain what that is. So if you want to know, go look it up. All right, now we need to break our shader up into subshaders. Subshaders are ways of defining different functionality for different parts of the shader. And you can set up different ways of handling the shader based on different parameters. Now we're going to set some tags for this subshader. The tags that we're going to set is the render type. And this is the main reason why we're writing our own shader as opposed to relying on the built-in shaders that come with Unity for projectors. That being, we want our shader to be transparent. This means we want it to be aware of alphas. The other ones are not aware of alpha, so we can't mask it out using an alpha channel. Q, I love this word, Q-U-E-U-E. Who invented that word? Equals transparent, and I'm going to have 100. That's just basically giving it a priority inside of the queue. Now, inside each subshader, we can do things in passes. Again, complex subject. Not going to dive into it other than the fact that we need one of them. Now, inside of our pass, we're going to set some properties for our pass, or not so much properties, but settings for our pass. One is going to be setting the Z write to the Z buffer to off. We don't need to do depth checks. We're going to set offset to -1 by -1. We're going to turn off fog because we don't need it. Matter of fact, we don't want it if our stencil is being affected by fog. It's going to look kind of weird. So we turn, oops, that was just lag. All right, now, because we're using transparency, we need to do alpha testing, and we're going to check to see if the alpha is less than 1. We're going to turn or set our color mask to RGB, and we've got to set our blend. So blend is going to be 1 minus source alpha by source alpha. Now we need to set our texture. This is going to apply our texture to our projector. That texture is going to be our stencil. Inside of here, we need to issue it some more commands. Basically, we're going to set our constant color to be what we assign in color. We're going to combine the two such that we're going to take our texture, we're going to multiply it by our constant color, which is just called constant. That handles the color part of it, and for the alpha part is 1 minus texture. No semicolon, that's a different language.
Indent.
All right. What? Yeah, I'll get to it. And this is the other part. This is what does all the magic to turn it into a projector as opposed to just drawing it across the entire mesh, is we set the matrix to be a projector. Not a project, projector. And we can tab in. So that gives us our very first shader. And it looks prettier than the default because I can't stand that style of indentation that they use. So let's go see if Unity accepts it or if it's going to hate us. Apparently it's going to hate us. Parse error, syntax error at line 22. Line 22. 1 minus source alpha. What did I type wrong? SRC, not C. Oh, man. Well, at least I was consistently wrong.
This is true.
If you're going to be wrong, stick with it. All right. So that's what you get when you're looking at your keyboard and not the screen. All right. Good. So no errors there. I'm going to clear this one because it's annoying. All right. So now, if we take our scene, let's clean this up, hit save, go ahead and run, and that'll get our projector out on the screen. So here he is. Let's go ahead and raise his position up to, let's say, 40. He's all purple, which is fine for the moment. Let's go ahead and tell it to use our new texture. There's our Sculpt Tool projector inside the projector folder like we expected. It turned everything red because that's our color that we've currently got selected. Let's select our material. I'm going to take our test pattern and we're going to see our very first problem. It's projecting, and it's projecting smaller, and it's not across the entire area like we want it to be, which is good. But everything else is black except all this red stuff out here, which is really weird. But this is a different problem. We'll cover that in a little bit. First thing I want to deal with is why everything is black except for this part that's red. And the reason this is because the other projectors, while they use black and white and levels of gray to adjust the effect of our projector uses alpha. So we need to go modify our test pattern. So if we take our test pattern here, I've got it set up to automatically open up in Photoshop. So if I take this, convert our background to a layer, select color range, select black, bump up the fuzziness a bit, try to get as much black as I can, delete all of our black, go ahead and go into layer, matting, defringe, and I'm going to take away 3 pixels. That should get rid of all of our black. Take that, save it out. I'm going to just overwrite our test pattern. I don't see the need of going back to it again. And if it does, I'll just make it. It doesn't take us that long to do. Go back into Unity. So now we've got this. If I go ahead and run again, take our Sculpt tool, let's bump it up to 40 again. Now, we've got some fun stuff going on. One, this is very brilliant red, which is awesome because that's what I wanted to do. You can't miss this.
No.
Well, you could if you're colorblind or blind in general, but it's really, really hard to miss. So we've got that in place. So it's using our alpha channel, but it's not using the alpha from the constant color. It only cares about what you're bringing in as far as the stencil. Now, the other issue that we have is if I start scrolling back, well, that was kind of weird, is all this red. Now, this red is coming in because of MIT mapping. So if I take our test pattern and we look at it, we're using a 512 by 512 texture. We're using the standard texture. If I swap over and go to advanced, we have the option to disable MIT map. If I turn this off and hit apply, all that goes away. The trade-off, though, is depending, I don't know if you can see this. I can't see it on my side, but when I use a stencil that has really fine detail, I find that you lose anti-aliasing around the edges. And then depending on your distance from it, this can look very pixelated.
Mm-hmm.
And that's the sacrifice that you lose by turning off bitmaps. If you find that it's unacceptable and you need to use bitmaps on your textures for your projector, what I recommend doing is padding in your stencil. So I gotta hit apply. So what you do is you draw your stencil much smaller than you need it, and add more area around it. So if I go to our test pattern here, and I take our test pattern and I dial this down, I save it out again. What we've done is we've added more area around it so that when it gets scaled out for the mip mapping part of it, it takes many more levels of mip mapping before it gets picked up. So you can see that a lot of the noise came in, but at extreme mip maps, it's still showing up. So what we may end up finding is it's going to be a compromise, especially if you were trying to project something on, our real or one of our other R&Ds that have the entire planet surface available that goes out to 100K or 50K or 50 kilometers in any direction. So, but if you run into this type of stuff, usually it's mip mapping, and the way you fix it is by adjusting your image so there's more padding around the outside of the image. So the trade-off, though, is it requires larger textures or you lose detail in your texture. So I'm going to go back to Photoshop real quick. I'm going to undo this and save it because I'm not too worried about the size for now. Mostly because it's just a visual artifact and we're not going to be keeping this permanently, but I like to have it a little bit larger. So that gets us our very own custom shader, the first of all the R&Ds, I believe. Matter of fact, I know it is. So, at least for the stuff you guys saw.
Alrighty. So is that everything that you wanted to cover right here?
Yep, for this one.
Alrighty. And with that, that's going to wrap up this video.